Now I want to talk to you a little bit, very related to what we just did. I want to talk about the difference between a touch point, a cross point, and a turning point. So let's take a look at this graph. This is a graph of this function, x minus 1, x plus 3 squared. Now that means that my zeros are 0 from this term, positive 1 from this term, and negative 3 with a multiplicity of 2. Now let's take a look at the differences between those points on the graph. X equals 0, notice it's crossing through the point at 0. That had an odd multiplicity because it happened one time, and 1 is an odd number. X equals 1 is right here, and notice the function crosses through that point. Also an odd multiplicity. This has a multiplicity of 2, and look what happens at negative 3. My graph comes down, touches it, and then comes back up again. So that would be a touch point and also a turning point. So it touches it, and it also turns and goes in the other direction. So it is possible to have a turning point that's not a touch point. In this case, we would have both a touch and turning point because it's an even multiplicity. So a touch point and turning point on the x-axis, odd, it crosses through it at that point. In a future lesson, we will talk in much more detail about how to graph polynomial functions. For now, I just want us to get a rough idea as to what the graph would look like. So I'm going to look at a couple of things. First, I'm going to go ahead and plot all of my zeros. So if I set this equal to 0, I would get x equals 0 with a multiplicity of 2. That's even. That's that touch point. So at 0, it's going to touch and go the other direction. Another 0, if I set x plus 4 equal to 0, I would get negative 4. And that's an odd multiplicity, so it's going to cross. So it's going to cross at negative 4. X minus 7 to the third. So again, that would give me a positive 7 with a multiplicity of 3. Again, that's odd, so it's going to cross at 7. Now again, we're doing a very rough sketch, so I'm not going to worry about any of the other points. I do want to see what the overall shape would be. So 2, 3, 4, 5, 6 x's means it's even, which means it's going to start and end in the same direction, but it's negative. So I know that in general it's going to be down, and then it's going to do something like this, and it's going to end up coming back down. So 1, 2, 3, 4, 5 turning points. We'll talk more about that in the next part of this, but that's how I know how many little humps it could have. I also know that it should be starting down here. When it gets to negative 4, it should cross. And then I know it's going to touch at 0. This is a touch, and it's going to turn around and go in the opposite direction. And I don't know if it's doing something else up here, but because we have taken care of all of our degrees, I'm just going to do this, and I know that it's going to cross at 7. So there's probably something else going on, but this gives me the basic shape, is that it's negative infinity here, and here's where it's touching or crossing the x-axis. Let's try again, same idea. So I'm going to have a 0 at 0, and that has a multiplicity of 1, which means it crosses at 0. This one would give me x equal positive 1 with a multiplicity of 1, which means again it's going to cross at 1. And x plus 3 gives me an answer of negative 3, or a root of negative 3. And again, that's odd, and so it's going to cross at that point. Notice that my leading coefficient is positive, and my highest degree would then be 3. So it should look something like this. So that's how I'm going to draw my graph, and it's crossing at all of those points. Now, do I know that I did a good job on the other points? No, but that's okay because this is a rough sketch. We'll get more detailed the further into this unit that we go. Here's a question for you to try on your own. So press pause, try this question, then press play to check your work. I would start by setting x equal to 0, which gives me x is 0. That's a multiplicity of 1, and so it's a cross point. So at 0, my graph should cross. Set x minus 1 equal to 0, and I get x is positive 1. But that has a multiplicity of 2, which is even, which means it's a touch point, which means it should not cross at 1. And then x plus 3 equals 0 gives me x is negative 3, but that's a multiplicity of 1, which is odd, which means it's going to cross at negative 3. So negative 3 and 1. The other thing I need to know is the degree. So I have a degree of 1, 2, 3, 4. So I have a degree of 4, and it's a positive leading coefficient, which means it's going to look something like this. Positive leading coefficient. It's going to be a W type of figure. So now I just have to make that work here. I know at 0 it's going to cross. I know at negative 3 it's going to cross. And I know at 1 it's just going to touch. It's going to start up here. It's going to cross. It's going to cross. Here it's going to touch and then keep going. So this is a very rough graph. If I wanted to be more exact, I would have to find some points between these two x-intercepts and between these two x-intercepts to know what the graph would really look like. We're not going to do any questions like this on our own, but I did want to tell you about a turning point that's not a 0. So on all of our other questions so far, all of our even multiplicities were a turning point and a 0. Notice here in this graph, this does have 2 turning points, but it's not any of the zeros. So the zeros would be, the points here that I've plotted, but the turning points would not be the same as the zeros. So in terms of finding the turning points, that's a little bit more complicated, and we're not going to worry about that right now. But what I do want you to understand is that the maximum number of turning points is n minus 1, where n is the degree of the function. So this is a degree of 3. So at most, this will have 2 turning points. So notice here, turning point number 1, turning point number 2, and that's how we find those turning points. So at most 2 turning points. If it had a degree of 5, there could be 4 turning points. And so when I was looking at my degree of 4 and saying it was a W, that's 1, 2, 3 turning points. That's how I was doing that.